Hey there YouTube, Arvin69 here, and today we're getting back to 3D printing. More specifically, we're getting back to my old CTC 3D printer. I'm going to talk you through how I diagnosed a problem with this printer. It was a very troublesome problem with extrusion, how I solved it, and how I fixed the issue by swapping out the old Mightboard on the printer for a brand new MKS Sbase printer. So before we start, we'll get through the disclaimer. If you do attempt to do this on your printer and use this as a guide, please note that you do this at your own risk. I take no responsibility. And as always, when you're dealing with electricity, please play safe, be safe, and make sure everything is unplugged and all connections are double, triple checked. I carry no liability for this, and I carry no responsibility if you break your printer or electrocute yourself or anything else. So do this at your own risk. Also, before we get into this, there will be links to all the parts, all the files, everything I've used and the tools I've used in the description down below. So if you do want to follow and you do need any of the parts, please check the description for any parts you may be missing. So let's start the journey. Back sometime in September 2018, we had a power cut here in the house. When the power came back on, started to print a few days later and noticed that extrusion out of the hot end here was a little bit hit-y-missy. I was getting very, very bad layer adhesion. It was skipping layers and all sorts of weird problems. The printer was moving fine in the X, Y and Z coordinates. It was purely a problem with extrusion. Now, I don't use the right extruder on this because leveling both nozzles is a royal pain in the ass. So I've disconnected that a long time ago. I only use this nozzle here. Now, the profile I've been using on this printer is one I've been using in Simplify 3D for over a year now. So I know the profile is pretty well dialed in and it does yield very good prints. I've had some really, really good prints off this machine when it was working fine. However, I did tweak the profile a little bit to see if I could resolve my issue, increase the extrusion multiplier, etc. Nothing seemed to work. I still got inconsistent layer lines when I was printing out on the printer. So the next thing I did was that I've got an MK8 spring-loaded block on here, was to change out the spring in this to see if it had maybe lost tension with the heat, etc. But that didn't solve the problem at all. I was still left with inconsistent extrusion. So to help identify the problem and see what was going on, I dropped the print bed all the way down to the bottom of the printer here, heated the nozzle up to about 210 degrees and started feeding filament through at a constant rate and watched the filament extrude. Now, not the most exciting thing to do in the world, but it did show me that every now and again the stepper motor would stop and then pick up again extruding. So there was something in the communication between the stepper motor extruding that was causing a problem. It was just stopping the extrusion. So to try and identify what the problem was, I unplugged the stepper motors, the left and right, swapped them over, plugged them back in again, and ran a test before I put filament in to make sure it was moving in the right direction, that feeding the filament in would actually feed the filament. And then did the same test again, had the print bed dropped all the way to the bottom and fed the filament through when it was heated at 210. And again, unfortunately, we had the same problem. The motor would periodically stop extruding and the filament would just sit there for a couple of seconds and then start feeding again. So that ruled out the stepper motor wasn't the issue. So the next thing to do was unplug the cables that connect the stepper motors here, swap them over. Maybe there was a break in the cable. Before doing this, make sure you do unplug your printer. So anyway, swap the cables over, checked again that the extrusion would feed the right way, ran the test again with the print bed at the bottom, 210 degrees on the hot end, started the feed. Fingers crossed this would fix, because at this point I was starting to lose faith in the printer, and if it was this board that was at fault, I honestly had no idea what I was going to do. So with that said, I ran the feed through, and unfortunately the problem still remained. Every now and again the stepper motor would stop for a couple of seconds, filament wouldn't move, and then it would pick up again and start feeding. So this to me left only one conclusion: there was a problem somewhere on this Mightboard. Now unfortunately I'm not very good at electronics, so I had no way to identify where the problem on this board was or even any clue how to fix it. So this left me with a big problem. I had a printer that was my very first one, loved this machine to bits. Unfortunately I couldn't print on it. So at this point I took to the internet. I went to the CTC forums and Facebook, and I found a few people talking about a board called an MKS Sbase board. And what they'd done is they'd ripped this out of their printer and they'd swapped it over. Now, theirs weren't particularly because of problems with extrusion. They just said that they weren't happy with the quality that this printer was giving with a stock board. And they found that they had better print quality, etc. with this MKS Sbase board. Now, at this point, I figured I had absolutely nothing to lose. I had a printer that wasn't working. So I went on the internet and bought the MKS Sbase board and proceeded to try and connect this up. Little did I know at this point how much of a steep learning curve this was going to be, and how little help I would find on the internet on how to connect this printer up to an MKS Sbase board. So fast forward about 8 months, a lot of swearing, a lot of headaches, And quite a few threats to see if this machine would fly if I chucked it off the roof of the house. I actually do have a working printer again. Yes, this old beast is back and working and printing lovely again. So let's take a look how I wired the stepper motors and everything else up to the MKS Sbase board and how I got it working. And if you are watching this and this is a project you're hoping to undertake yourself, I hope this will give you some sort of value and maybe some guidance on connecting this up yourself. First, I started on getting the stepper motors connected, as I figured it would be the easiest thing to do. So after disconnecting them, I had to figure out how to wire them up to the new MKS Sbase board. After some reading, I found out the stepper motors have 2 pairs of connections to them. And to tell what 2 wires are in pairs, just connect the 2 wires together and try and turn the motor by hand. If there's resistance on the motor spindle when turning it, you've found a pair. Once you have the pairs, just refer to the pinout diagram from the MKS board and make sure you connect the X stepper to the X stepper on the board. Just here. Then all I had to do was repeat the same process for the Y and the Z stepper motors. So with these connected, I figured now would be a good time to test and the stepper motors were working and moving. That way I was only working on small problems at a time. So what we need to do now is jump over to an editor, just a WordPad editor, for the SmoothieWare firmware. What we need to do is to get to the section that deals with the pins for the stepper motors. As we can see, it's listed as alpha, beta and gamma. That refers to X, Y and Z in that order. Armed with a pinout sheet, we can start to set up our steppers. If you want to pause the video at this point, please feel free to do so and note down these figures that I've got set for my stepper motors. I'll be showing each of the config sections in turn, so feel free to copy down the details on each section if you need to. So, looking at the X stepper motor, we need to set the stepper pin signal. That will be 2.0 on our board. Next is the direction pin. For us, that's 0.5. And the enable pin, and that's 0.4. And then lastly is the ground connection. Once we have this done, we need to repeat the process for the Y and Z steppers. And what I did was I tested this by connecting the printer via a USB cable to Pronterface and sending the G-code to move the steppers. If you find your stepper motor is running backwards, just put an exclamation mark at the end of the direction pin to reverse the direction that it'll move in. There's some really good instructions for this on the official SmoothieBoard site, and I would recommend having a read of those. After doing some research on the steppers, I found that the current may be too high and that was causing the noise. Once I dropped the current to 0.7, this solved the issue and the steppers were running silently again. Now, with the X, Y and Z steppers all connected and all working, next for me to do is to set up the extruders, which are E0 and E1 just here. And not forgetting to refer to the pinout diagram to make sure you get these wired correctly. Again, the same method can be used to find out the pairs on the stepper motors as we used for the X, Y and Z. Simply touch 2 of the cables together and try moving the stepper motor spindle. If you've got the pairs correct, you'll find resistance when turning it. So with those connected, now it's back over to the config file yet again to set up the extrusion for the stepper motors. So the first thing we need to do here is set the steps per millimeter. This will determine how many steps the stepper makes for each millimeter of filament extruded. Now there is a calculation for this on the official SmoothieBoard page, but when I ran the numbers on this on my printer, it just didn't seem to work for some reason, but we'll come back to that in a little bit. I left most of the settings here as default, but as before we need to set the step pin, direction pin and the enable pin as per our pinout diagram. These steps are for both E0 and E1, or as they're called in the config file, hot end and hot end 2. As before, if your stepper motor is moving backwards when you run the test through Pronterface, just put an exclamation mark behind the direction pin and that'll reverse the direction of your stepper motor to move in the right direction. So at this point I've had some ups and downs and I've had some real struggles with this printer, as a lot of this is new to me. But on the plus side, we have the X, Y and Z stepper motors all moving in the right direction. We also have the stepper motor for the extruder moving in the right direction. Now the next thing to work on is this printer has micro switches for end stops. Let me find where this one is. It's just on here. So there's one here, one over here and one behind the print bed there. The next thing I had to do was work out how to get these connected, and this is where I hit another problem. You see, on the MKS Sbase board, there are 3 pins to connect an end stop up to. My end stops have 4 wires coming out of them. So I wasn't too sure which 3 wires needed to be connected and which one could be left. So I had to take to the internet and do an awful lot of reading, an awful lot of research, and eventually I did find out which wires I need to be connecting to which pins on the MKS Sbase board. So if we take a closer look at the pinout diagram for the MKS board, we'll have a look at the end stops. So looking at the pin diagram, we can see there is a signal, which is the P number, ground, which is the GND, and the voltage connector, which is the 5V for each end stop. Also for each end stop there is a positive and a negative end stop. Now when these were connected to the original Mightboard, the X and Y were on X and Y max, so I figured on the MKS board that would be X and Y positive. The same for the Z, it was connected to Z min on the Mightboard, so I figured that would be Z negative on the MKS board. So back to what wire to connect to where. I found out that on mine the yellow wire is the signal, which is the P number, black is the ground, the GND, and the red is the voltage, the 5V. So with this armed, it was time to connect these up, and once they were connected, it's back into the config file yet again to set these up in the config file. Now this isn't the prettiest section in the config file, and I'm by no means an expert on this, but my many trials and errors of setting this up, this is what I ended up with, and it works for me. So to get to this point was a lot of homing commands sent to the printer via Pronterface and a lot of editing of this file. Honestly, I think I spent the most time getting these things working compared to anything else so far. Anyhow, as you can see, sections of this have to be commented out. As if you're using min for the end stop, you have to comment out max, and vice versa, if you're using max, you have to comment out the min end stops. Also, you see I've had to invert some of them and put the hat symbol, or the caret symbol, as I've just found out that's what it's called. The hat symbol sets the pin to pull up over. So you remember before, the exclamation mark inverts the signal. The hat symbol, that is placed to pull up on the pin. Without this in place, my end stops would never ever trigger, even when they were pressed. So putting this hat symbol on causes the end stops to trigger at a high voltage value, from what I understand of reading this. But either way, it works. And don't forget to double check the pin outs for each of the end stops when you're entering it in the config file, as unfortunately I didn't, and I did make a mistake here and put the wrong pin in the wrong place. But I digress. Now most of the values here are left at the default. Don't forget to set the homing direction to correspond to the direction you're homing in. So for me, I have X and Y end stops connected to the positive, so I home to max, and the Z is connected to negative, so I home to minimum. I also set the max travel to greater than the print volume of my printer. This way the motors will move and eventually hit the end stops. If you want to speed up homing, you can alter the homing rate in the config file. Just take care not to run the motors too fast. So at this point, a few months had passed since I started this project. We've got the stepper motors working, we've got homing working, but unfortunately I'm only getting a few hours a night to work on this due to family commitment and work, so progress is very slow. But with all that done, I decided now is the time to start working on the hot end and hopefully get the final pieces of this project put together. Unfortunately, I hit major problems at this point. So my original plan was to use the original hot end assembly, which contained the heater cartridge and the thermistor of the original CTC 3D printer. Now those had been heating up and working and reading values correctly, so I figured they were probably fine. And luckily for me, the MKS Sbase board has connectors that accept those straight in. There's just 2 wires for each of them, so that was fine. Wired it all up and things didn't quite go to plan. So with the values set in the config file, I connected the printer via the USB once again to Pronterface and sent the commands to heat up the hot end and read the values of it. But for some reason, every time I read the value of the hot end through the thermistor, it was reading -50. And I couldn't work out why this was. Even when there was no heating command sent to the hot end, it was reading -50 degrees, which was a little bit strange, so I thought maybe it was the connections that were loose. So I redid the connections, tested it again, nothing was happening. So at this point I borrowed an infrared thermal gun just to see what the temperature on the hot end was, and I confirmed it was not heating up at all. So at this point I was a little disheartened, to be honest. I had no clue what was going on, I didn't know why this was happening. I tried everything I could think of. I tried all variations of the thermistor in the config file. I checked everything. Voltages were seemingly going through the Sbase board. I just couldn't work out why this was happening. So at this point, having no help on forums, I took to Facebook and went to the FYS TEC Facebook group to see if anyone on there could answer my question for me. There was a person on there called Miguel Perez. I think that's how you pronounce his name anyway. He read my question and he worked with me for a good few weeks trying to get this issue resolved, until eventually he found out what the root of the cause of the problem was. And that is the original CTC 3D printer doesn't use a thermistor to read the values of the temperature, it uses a thermocouple. Now the MKS Sbase board doesn't understand what thermocouples are, so I had to hit up eBay and buy a brand new hot end assembly with a brand new heater cartridge and a brand new thermistor in it. It was the cheapest way to do it. So with that in hand, it was time to wire that up to the board and give it a test. So in the config file for the hot end, I only had to make a few changes for this to get working once I had the correct parts. Right tool, right job and all. Setting the thermistor pin and the heater pin was already done, and you can refer back to the pinout sheet. That was straightforward. The only thing I did have to change was put the thermistor setting back to a Honeywell, as a SmoothieWare guide suggests that most thermistors that you could buy on the market work with this setting. Everything else was pretty much left to default. And we had a working hot end. So we have stepper motors, we have end stops, and we have a hot end heating up. All looking good so far. So the last part of the puzzle, or so I thought at this point, is the heater bed, and honestly this was straightforward to get working. Connected it up using the existing connections that were already on the printer already, straight into the MKS Sbase board. All I had to do was just the thermistor pin and the heater pin, referring back to the pinout diagram again, and that just pretty much worked straight out the box. So with all that connected and looking really good, the only things left to do were connect up the fans for the printer, and that is the fan for the hot end here and the fan for the part cooling part that I've retrofitted onto this printer. Now the hot end fan was dead easy to do. There is a port on the MKS Sbase board labelled fan, so it's just a case of connecting the two wires, the positive and negative, up to those, and that works straight out of the box. However, I did go a little bit deeper and set a switch on those, so we'll dive into the config file and we'll have a look at that. So as I said, I went a little bit deeper on this cooling fan. What I wanted it to do was, when the hot end reached a temperature of 60 degrees, the fan would kick in and start cooling down the parts. So as you can see in the config file, we've got a command called switch, which I read up on the wiki page for this file. Once I got that all set, you can by all means pause the video and copy the settings down. This actually worked straight out of the box and was pretty much a direct copy of the example that was set up on the wiki page. So that was fairly straightforward. Now the next fan to set up was the part cooling fan. Now there were no more fan ports available on the MKS Sbase board. However, there is a spare hot end connector, as I don't plan on using two print heads on this printer, so I decided to connect that fan up to this one. So as we can see here, there is a connection labelled fan, and that's what I used to cool the hot end down with. And we have heater 1 and heater 2, and heater 2 is what I've connected the part cooling fan up to. And you can see there is a wire that runs off down and out of camera shot here, but that goes down to a switch on the front of the printer, and that was a leftover from my original CTC days, so I can turn the fan off and on manually. So I left that in, but the connections are straightforward, positive to positive, negative to negative for this fan. So let's jump over to the config file and have a look. So in the config file, I've created a new section called part fan. I had to set up input on command and input off command to allow me to turn the fan on and off in the G code with the the M106 and the M107 commands when I needed it. Other than this, all of the settings are default from the manual at SmoothieWare. So with the part cooling fan connected to a manual switch, as I said before, this is all done and dusted, and I've now got control of the fan either from the front of the printer or from G code. Now there is one more fan to connect up to this, and that is to cool the MKS Sbase board. Now I'm not sure if this fan's needed or not, as the board does have heat sinks here and here. However, the old Mightboard did have a fan running air across the board to keep it cool, so I figured I would do the same. The only problem I've got is there's nowhere else to connect a fan to on this board that is readily available, or that I knew about at the time. So what I did, I went out and bought a MOS driver. So with this, what I've got is there's cables coming out of here going into the power supply just down here, and that connects the 12 volt DC direct to this. From here we take power out of here, connecting to a 120mm 12 volt DC fan that I've got. I've actually taken the fan off so you can see it, but for reference, this is the fan. And then to get the actual fan to come on, we do need a signal coming in on these pins here. So what I've got is on the SIG pin, that's connected to a 5 volt connector up here, spare one. And then the GND is connected to ground up here as well. So that simulates a switch always being connected. So when I turn the printer on, it gets power, 5 volt is activated, signal sent to here, and the fan starts and starts blowing cold air straight onto the board. Now the only thing left to do was to connect up the touchscreen for the printer so I could control the machine via an interface once it was all working. And that's what this cable here is connected to. It runs under the board and down to this little box that I made on the side there. So we'll have a quick closer look at that. There's not much to set up on this, so we'll have a quick close look. So there we are, that is the MKS TFT screen. This is the custom housing that I made for it to connect to the front of the printer. As I said before, the files for this are down below in the description. Now to get the screen working, all you have to do is a very simple config file. Make sure that it's set to SmoothieWare, and that the printer is set to Delta or Cartesian depending on what type of printer you're using. It is very, very simplistic to set up. So once I had the config file set up, powered the printer on, tried the screen, pressed the home button, everything homed perfectly, started to heat the hot end up to 120 degrees just as a simple test, and lo and behold the fan came on and the hot end heated, so we were all good. At this point I was beginning to think the printer was going to be back to life again and things were going to get back to normal. With everything set and everything looking good, it was time to get the home point set and time to get the details updated in the Simplify 3D FFF file. Now to get that done, I hooked the printer up once again to Pronterface via the USB, moved the print head along with the G commands, and then fired the M114 command at Pronterface to get the location of the print head. With that information, input it into Simplify 3D, and hopefully we'll be able to start printing, and when it starts, it should be in the center of the print bed. However, when I did start printing, I noticed that it was slightly off, so it was just a simple case of working out which direction it was off in and modifying the offset origins in Simplify 3D to match and get it centered correctly. And you can see those details on the bottom of the screen here. If you want to copy them down, feel free to. So now with the home point set and everything looking good, it was time to run my first print. And the first print I ran was a calibration cube that I found on Thingiverse. It's a 20mm calibration cube with X, Y and Z embossed on the sides. Unfortunately, that is not a 20mm calibration cube. That is the first 20mm calibration cube I printed on this printer once I got it working. It's not 20mm by any stretch of the imagination. It's more like 10mm by 20mm. So at this point I know pretty much the Z-axis may be working, but everything else isn't. Also, not to mention the layer lines are really, really poor on this one. It's very, very poor adhesion to each layer, and there's also gaps again. So yeah, needless to say my heart sank at this point was an understatement. So as you can tell from print number 1 that we do have a problem with the way the stepper motors are moving in the X, Y and potentially the Z direction. They're not moving enough. So it was back into the config file, tweak them and run another print. As you can see, the first one I dialed in the Z settings, it was way off. So I figured, well, go for broke, let's do all 3 of them. And we started to get cubes that more resemble the 20x20mm size that we were expecting. Now these are all in order of numbers 1, 2, 3, 4, 5, 6, 7 and 8th attempt. And by the 8th attempt, I'm starting to get the figures dialed in a little bit better. The figures I showed you in the config file at the start there, they were my final ones and them ones do work. However, these were the first 8 cubes I'd got done, and at this point we're starting to get in. So I continued on printing more cubes. Let's move on to the next batch. So this was cube 8, which was the last print I did, and at this point the settings are almost dialed in. It's 20mm in the X and Y, the Z wasn't quite right. So by print 9 I've dialed in using the digital calipers. We've got 20x20x20. Now, hopefully you can pick this up on the camera, but the layer adhesion is really, really bad, and it just seems to get worse up until a point where it just splits off completely, and we have very, very, very poor infill on the center of this. So there's a close-up of some of the cubes, and you can see the layer lines are really, really bad, and as I said before, the infill in there is absolutely atrocious. And at this point, I just killed the print because it was doing really, really bad. So I was beginning to think at this point maybe the filament was to blame and it had been out for too long and absorbed moisture. So what I did was I grabbed a roll of the translucent red PLA that I've got, and I know this has been printing fine on my Prusa printer. So I fired that one up, popped it in, and unfortunately I still had the same problem. It wasn't very good. The layer lines were really, really bad. So we've got some definite banding, and on the top here it's not printing very well at all. So at this point, I'm feeling very disheartened, and the fact that maybe months and months of learning and playing about with my printer might have been all for nothing. However, at this point, a video cropped up on my timeline suggesting running an oiler through the filament. Now, this hadn't crossed my mind before because my CTC printer used to print perfectly fine without oiling the filament. However, at this point, I figured I had absolutely nothing left to gain or lose, so I figured, what the hell. Printed one off on my Prusa, run it through the printer. That was the first result. That was the second result after the oil had been fully pushed through the nozzle. And to be honest, it is absolute night and day the difference between the two. before the oiler, after the oiler, and in comparison, that is a cube that has been printed. In fact, we'll use the same filament. That one has been printed on my Prusa printer using exactly the same blue filament. These came off the CTC, this came off the Prusa. It absolutely works. Now the oil I recommend using is a cooking oil, an extra virgin oil. That's what I've used on mine, and it's literally just a couple of dabs on a sponge to run across the filament, and it just works. To be honest, at this point I was completely elated. I had a printer, it was back, it was working. Couldn't believe it, my original 3D printer was back into life again. Now with the printer dialed in and working, I decided to start printing off a project on this printer, and that is a small vise that I'm going to use to help me when soldering small parts. These are some of the parts I've already printed so far, and they have come off fairly well. I think the profile needs to be tweaked a little bit on the printer now from what I used to use, as the overhang on this didn't print too well. It's printed in this orientation. However, I'm actually fairly happy with this print quality. It's doing really, really well. And I do have a time lapse of this printing. So if you've made it this far through the video, congratulations, well done, and thank you very much for watching. Like I said, if this is a project you're planning on doing in your printer, I hope this provides you with some detailed instruction, or at least some help to get the project started and at least maybe finished. Do me a favour, if you enjoyed the video, please smack the thumbs up or the thumbs down button, but please leave me a comment below and let me know what you thought of the video, and also if you can mash that subscribe button, subscribe to the channel, helps out immensely. Till next time, happy printing and take care.